Welcome to Translating Word Problems, Day 2. Last day we looked at problems where we had, tickets and, different price tags of tickets or maybe some different coins or bills being involved and having to develop equations. So today we are going to look at problems where we're just talking about a couple numbers involved and how do we go about solving for those numbers. Okay, so I've left the first part of the note the same as before, so that you know that you are going through the process of um, defining variables first, creating equations, and then we will eventually get to solving and checking the solutions and writing our final statements. All right, for now, let's just get right to the number word problems. Okay, so today you're just like last time, we're going to be building two variables and two equations here. Okay, so the difference between two numbers is 63. When the larger is subtracted from twice the smaller, the result is 49. Okay, find the answer. So again, what we're going to be doing today is we're going to be going through and writing the variables out and building some equations. So analyze the problem for what it is that you need to find. So usually it's in the last part of the problem. It'll say find this. Okay, so in here, find the numbers. Well, how many numbers were there? There were two numbers. And there's some qualities about them that one was larger, one was smaller. Okay, so just gonna add that to your table here as you're brainstorming. So we know we have a larger number and we have a smaller number. Okay, all right. And then now we're gonna assign them letters. So again, it doesn't matter if you want to use L and S or I'm going to just use X and Y. If you wrote smaller number first, that would have been fine. If you wrote a larger number next, that's okay too. Okay, so just make sure match it up with the letters and kind of use the letters according to what the problem's saying, and you still will get to the same answer as someone beside you who did it the other way. Okay. All right, so since we assigned those letters, those variables to those descriptions, we're just going to write it out here. So X is going to be the larger number that we have to find. Okay, so again, make sure that you are writing the larger number and not just number one, number two, because there is a definite difference here. There's one that's larger, one that's smaller. And then don't just write larger, smaller. You have to actually write number, okay? And then check, are there any units? Okay, so these are, you're actually finding like specific numbers, so there's no units to them, so we don't have to write units. Okay, but keep checking that. You're going to find some questions coming up that you have to write the units in. Okay, so the first sentence there is the difference between the two numbers is 63. So difference, you should be able to translate it as meaning subtract. And between the two numbers is, means equal sign, 63. So see how the answer is a positive 63. So you know you have to have the larger number subtract the smaller number. So that's important which way these numbers go. All right, so if you're taking the larger and you're subtracting the smaller, you should be getting, so I guess if the negative there is, or subtract there is confusing, I could write it here, x minus y equals 63. Okay, so there's our first statement complete. All right, so the next one is when the larger is subtracted from twice the smaller, the result is 49. So again, just kind of write in things to help you translate it. The larger, okay, what am I using to represent larger? The x. So when the larger is subtracted from twice the smaller, so twice means multiply by 2, and the smaller is y. Okay, and again, like we saw last time, sometimes the subtract, like it comes first in the sentence, but it means we're taking it away from something here. So when the larger is subtracted from twice the smaller, the result is 49. Okay, so the larger is subtracted from twice the smaller. So you're taking the larger and subtracting from twice the smaller. So again, you can kind of write this wherever in here. So if we're taking the smaller, so if you find that writing it up and down is a little confusing, you can write it sideways here. So twice the smaller, okay, the larger is subtracted from this. So the larger is x, right? So again, you're just going to build something and keep reading it. So when the larger is subtracted from twice the smaller, the result is 49. Okay, so just kind of keep reading it going, oh yeah. So the larger is subtracted from twice the smaller, the result is 49. Okay, so now we have our two equations, so we can write them in here. Okay, so example 2. All right, so calculator is thinking of two numbers, okay? The sum of the two numbers is 6, the sum of the larger number and 3 times the smaller number is 8, okay? What two numbers is Cal thinking of? I'm just gonna bump this down to give us more space to write on the question. All right, so from here, I want you to think about, again, what is it that you have to find? That's the first part. Okay, it's usually located in the last statement here. What are the two numbers? So again, you see that there's two numbers, and you always want to look for inequalities like, is there a smaller and larger number? If there isn't, then you can just write first number, second number. But again, there is a smaller and larger number, so it doesn't matter again which way you write it, but just specify that one is larger and one smaller. Okay, and again, pick some variables and label them to those numbers. Okay, and then make your statement here. So let x be the larger number and y be the smaller number. Okay, and are there any units? Nope, just because we're just identifying numbers. Okay, so from there, start looking at the sentences and going through and trying to translate. Okay, so the first sentence here, the sum of the two numbers is 6. Okay, so hopefully you're comfortable whenever you hear sum. A lot of people say equals, but again, to get it to equal, what are we doing? We are adding them. Okay, is 36 is 6, so is means equals. So you're taking the larger and the smaller, summing them together, and you're getting 6. All right, so we've developed our first equation. All right, let's look at the next sentence now. The sum of the larger and, so again, there's the word sum again. So we know we have to add something. The sum of the larger and 3 times the smaller number is 8. So again, feel free to use these boxes in whatever way helps you kind of organize it in your head, okay? So I'm taking the larger and I'm summing it with 3 times. So like here, 3 times, right? The smaller number, which is y. So if I'm taking the larger, the sum of the larger and the smaller number is 8. Okay, so again, is means equals 8. So again, kind of set something up and kind of go back and read the sentence again and go, okay, does that make sense? The larger number, the sum of the larger number, and 3 times the smaller number is 8. Okay, so then you got to translate it, all right? And then write out your equations. So again, the work step here, the work box, it's not necessary. If you can just translate it to here, that's fine. But I'm finding that people do struggle with translating word problems. So kind of laying out the information like this is helpful, okay? All right, and then don't forget to write your variable statements. Okay, so on to another example here. So again, today is just all about, here are some numbers, find the numbers, and so forth, okay? All right, example 3, two numbers differ by 5. 4 times the smaller number is 5 less than 3 times the larger. Okay, so you're going to go through here and again think of what it is that you have to find. So again, we do have a couple numbers here, and again, some are smaller, some are larger. So write them out, okay, with those details. All right, and in this case here, I'm just writing the smaller one first to show you that it doesn't matter which way you write it, as long as you are still kind of being consistent as you go through the problem, okay? So I'm going to call this one X, and that one Y. Again, if it really bugs you, you want to keep the letters the same, you can put the larger first and the smaller next, okay? All right, so X is the smaller number. Y is the larger number. And so then we're going to go through and translate here now. So we have two numbers that differ by 5. So what does that mean, difference, okay? So you know when you take the numbers and you subtract them, the difference in them is 5. So, so again, the order that you write these is important. So I happen to just write smaller first in my work box here, okay? But when you actually write this expression here, because the answer is positive 5, you know you have to have the bigger number first, because if you don't, you're going to end up with a negative 5. So in here, if you wanted to just kind of jot down, you need to have the larger subtract the smaller equals 5. Okay, so that's the first expression that you have. Okay, so that one's done. Let's go to the next part now. Now, 4 times the smaller number is 5 less than 3 times the larger number. So find the numbers. So what we're going to do here is just again go above it and add the details. So 4 times, okay, the smaller number. So we're using x here, is, so is, okay, so is always equal, is. All right, so we have, just remember the 5 less, right? So that means subtract 5. But again, we're seeing that when they write it like that, it's coming before what it's being subtracted from. So 5 less than 3 times the larger. Okay, and the larger is y. So we're taking 3 times the larger, 5 less. So we're going to subtract the 5. And it is the same as 4 times the smaller. So 4 times the smaller is 5 less than 3 times the larger. So let's translate that. So you have 4 times the smaller is, and then 5 less than 3 times the larger. So we're going to write 3 times the larger, 5 less, like that. Okay? All right, so just, it's a good idea to like take the sentence and then start translating above and then creating the equation. So anyway, so let's write out the equations here. So we have y minus x equals 5, and then we have 4x equals 3y minus 5, like that. Let's move on to example 4 now. So we'll just move down here. So we have an age type question. Okay, so still dealing with numbers here, but specific number, ages. Okay, all right, so read through and make a decision on what information you have here. Okay, so we have Andy and we have Ashley. Okay, so twice Andy's age increased by 3 times Ashley's age is 93. So 5 times, so the next sentence is 5 times Andy's age decreased by 4 times Ashley's age is 37. Okay, I know no one talks like this, but just get comfortable just translating it. We can do these. You can translate a lot of questions here. All right, how old will Andy be in 10 years from now? Okay. All right, so let's go through here and start building some stuff, information. There's a lot of information here, okay? So we have Andy and we have Ashley. Okay, so it's their age, so we're just gonna go X and Y, all right? So let's make our let statement here. Okay, so let X be Andy's age. Okay, and we're talking about right now, like, so now. Okay, I know it was talking about from 10 years from now as well in the problem. So I'm just going to write now, this is Andy's age. Okay, so again, always be checking for units. So in this case here, when we have to calculate out the value, are there going to be some units? Yes, because we need to find out the age of these people. So you would write 5 years old, 10 years old, and so forth, right? So years will be the unit. All right, so that's the first time we've seen that. So just always be checking for it. You need to do it to get full marks, okay? All right, Ashley's. So Ashley's age. Okay, so this is going to be their age right now. All right, so X and Y. All right, so let's go through and translate these problems here. So twice Andy's age, so twice means multiply by 2. Andy's age was just X, increased by, okay, so it's the first time we've seen this, but increased by, so that just means to, add, okay, So if you had 5 donuts, you increased by 3, you added 3. Okay. Times, so that means multiply. So it's Ashley's age. Okay, and is 93. So a lot of stuff going on in that sentence. So we have twice Sandy's age increased by 3 times Ashley's age is 93. Okay, so again, write this wherever. If you don't like the boxes, you can always do it in an empty space. So, so we have twice Andy's age. Okay, increased by 3 times Ashley's age. Okay, is, if you add them together, 93. Okay, so twice Andy's age increased by, so added by 3 times Ashley's age is 93. All right, so that first sentence is done. All right, let's go to the next one. 5 times, so 5 times Andy's age. So Andy's age is X. Decrease by this time, decrease. So let's subtract. Decrease by 4 times Ashley's age is 37. All right, so let's translate that now. So 5 times Andy's age. Okay, decrease by 4 times Ashley's age. So decrease by, so we're going to do subtract this time, is 37. Like that. All right, and then so we have our 2 equations built. In this problem here, there's going to be like a third part to it. So when we have to actually calculate these out, we have to take into account. So if we just add another column here. So I add another column here. So this will be like the third sentence that is involved here. So we're going to use, we have our variable set up. We have these 2 equations to help us get to our answer for their age today, like now. But then when you go to do the next part of this question, there's a third part. So once you get the answer, it says, okay, great, you have their age, but I want to know how old will Andy be in 10 years from now. So basically 10 years from now, okay, from now, what you're doing is you're taking Andy's age, you're adding 10, and that's what you're going to write as your therefore statement. And if we had to find Ashley's age, we would add 10 to that. Okay, so anyway, that is later in the problem, but you have set your goal today is just to set up the variables and the equations. So here are the 2 equations. All right, so we had twice Andy's age increased by 3 times Ashley's age is 93. And then we had 5 times Andy's age decreased by 4 times Ashley's age is 37. Okay, and then yes, just it's already hard enough as it is, but you should be able to take that one extra step and find that in a few days when we have to actually calculate the answers. Okay, but right now, if you got to here, good job.